Rahmatullahi wa barakatuhu. Today we are going to take a third class regarding application of matrices and determinant. As already we have discussed so many results and theorem. Last class I told you to remember all those results which is going to useful to us. Today we are come to the last concept of the first chapter, that is 1.1. We are going to come and conclude today. Let's see some problems here, and then finally in the last I will recall all those things. Last class I have given some 4 or some as a homework, 4 or 3 some as a homework. In that one is remembering the results and theorem I have said you. That's very important. Please remember, I am repeating, that is going to be useful for your 1 mark question. Okay, it's very important, so remember those things. I will solve 1 or 2 problems. Now we will have application of matrix and determinant. This example as I have given as a homework. Here what they are saying, verify the property A transpose a whole inverse equals to A inverse transpose. This we need to verify. Okay, where A matrix is given as 2, 9, 1, 7. Okay, I am going to take LHS, that is left hand side, and I am going to take RHS separately, and we are going to solve that one and we will get the value. So what the LHS is there means we need to prove A transpose whole inverse. We need to find this one. Okay, so A is what matrix is given. You know that 2, 9, 1, 7 is there. For that one I am going to take transpose. Inside the bracket is transpose. Transpose means you know that one we need to change row into column. 2, 9, first row will become first column, second row will become second column here. So row change as a column. So that we are calculated. Now we need to find inverse for this one. As we know that a shortcut method in 11th standard itself we have done. So how we are going to do? First we will find adjoint of A transpose. Adjoint of A transpose. This is the shortcut way. In this diagonal you just exchange. That is, this is 7 and this is 2. We have to exchange this one. And we need to change the sign of this one, -1, -9. So this is the shortcut way of finding the adjoint for any matrix. Here what you are going to do, exchange this number and change the sign of this one. You will get that automatically. What you are going to do, you are going to take a adjoint of that one. Now we need to find determinant of A transpose we need to get. That is determinant of 2, 1, 9, 7 we need to get. So what's that value? 2 7s are 14 and minus formula 9 1s are 9. So we are getting 14 minus 9 is 5. So mod of A transpose is we are getting this one. So according to our LHS, what we need to get? A transpose. For A transpose we need to find inverse. What's the formula? 1 by determinant of A transpose adjoint of A transpose. You may think that what's the formula now? You consider A transpose as B. So this is B now, this is 1 by determinant of B adjoint of B. That easily you will get it. So here what's the determinant here? 5 is there. So that's the value. So we are getting 1 by 5. And adjoint of A is this one. What's that one? 7 minus 1 minus 9, 2. This is our first value, we can say LHS. Here we need to take here RHS. Separately we can do, or we can adjust also, our wish. Okay, first what's the A matrix is that? A equals to 2, 9, 1, 7 is there. Okay, so for that one I need to find A inverse. So that one I am going to find A determinant of A. 2 7s are 14 minus 1 9s are 9. Again I am getting what? 5. So determinant A I am getting as a 5. Now again shortcut adjoint of A. What you need to do? Exchange this one, that is 7 to change the sign. So minus 9 minus 1 will come. So we got the adjoint. Now you take A inverse formula. What is that one? 1 by determinant of A into adjoint of A you need to find. That is 1 by 5, and then this is 7 minus 9 minus 1, 2 you are getting. That is the value of A inverse. But our RHS is what is that? You need to take a transpose. So I am going to take A inverse transpose. Transpose is only for this not for scalar. Okay, it will applicable only for matrix. So it will become 7 minus 9 minus 1 2. That is first row 7 minus 9. Here become column 7 minus 9. First row, second row minus 1 2 become minus 1 2 here. So that is your equation 2. You can look here 1 and 2 are same. That is here 1 by 5 7 minus 1 minus 9 2. Here also what is that? 1 by 5 7 minus 1 minus 9 2. So here LHS equal to RHS. Hence the proof we have verified. So to verify this one, A transpose whole inverse equal to A inverse whole transpose, we have verified. That is the first problem we have done. I have given as the homework. In this way also you can do, or you can see your book, and in book also some different method is there. Not different, just small adjustment they have done. That method also you can follow. Next, the same way, this problem also I have given as a homework. 1.9, verify AB whole inverse equals to B inverse A inverse. This is nothing but inverse law we have shown. So here also we are having, this is LHS and this is your RHS we are having. So we will do separately for our convenient purpose. LHS, what we need to do means AB, for that one we need to do whole inverse. This we need to verify. Okay, first we need to multiply AB matrix. That is, A is what here? 0 minus 3 1 4, and B matrix is what we are having? minus 2 minus 3 0 minus 1 is that. This will multiply. As you know, 7 method you need to multiply. 0 into minus 2, 0. Minus 3 into 0, 0 it's coming. First row, first column is over. Next, first row, second column. 0 into minus 3, 0. Minus into minus plus, 3 ones are 3. So this is the value 3 we are getting. So first row, second column is over. Next, it's come to second row. 1 into minus 2, minus 2. 4 into 0, 0. Leave it off. The next one, 1 into minus 3, minus 3. 4 into minus 4, minus 4. That's the thing we are getting. So AB matrix we are getting as 0, 3, minus 2. Minus 3 minus 4 is minus 7 we are getting. So that's the thing. For this one, now we need to find AB whole inverse. So first we will find a determinant of AB we will find. So that is cross multiply 0 into anything 0, minus into plus, minus 2 3s are 6, minus 6 is that. So minus 6 will come. So determinant AB will come as 1 by 6 we are getting. Sorry, this is not 1 by 6, plus 6 we are getting. Alright, minus into minus. Now after this one we need to find adjoint of AB we need to find. We need to find adjoint of AB. Already I told you how we are going to find adjoint. This is AB matrix. So exchange this one. So it will become minus 7 0, shortcut method, and change the sign. Here plus is there, that's why it's a minus 3. Here minus is there, that's why it's a plus 2. That's the thing of adjoint AB. Now AB whole inverse we need to find. What's the formula? 1 by determinant of AB, adjoint of AB we need to get. So that's the thing we need to do. Here 1 by AB, determinant is 6 here, so it's coming 6. Adjoint of AB, this is adjoint of AB, that is we are getting minus 7 minus 3 to 0. We are getting this. This is your LHS, that we are going to make it as equation 1. Okay, simultaneously we will do RHS. What the RHS means? We need to calculate B inverse and then A inverse we need to find. So first we will find B inverse. So B matrix is this one, that is minus 2 minus 3 0 minus 1 is that. So determinant B you need to find, that is multiply minus into minus, plus 2 ones are 2. This is 0, leave it off. The next one, adjoint of B you find it, exchange this one. So minus 1 minus 2, diagonal, anti-diagonal, change the sign. Minus will become plus here, so plus 3. 0 is not having sign, so that's why you will write 0 as such. That's the thing we are getting. Now B inverse value is 1 by determinant of B, adjoint of B we have. So that's mean, so B inverse value we are getting 1 by 2, and this is minus 1 3 0 minus 2 is there. That is the B inverse value. Similarly, we are going to find A value, A inverse you need to find. A is 0 minus 3 1 4 is there. So first you need to find determinant A. As you know, 0 into 4 0, minus 1 into minus 3 minus 3, so plus 3. So the value of determinant A will be 3 here. After that one, adjoint of A we need to find. How you are going to find? Exchange this one, diagonal, mind diagonal, and change the sign. Minus 3 will become plus 3, plus 1 will become minus 1 here. So we are going to get adjoint. Now determinant A is there, adjoint is there. Now A inverse, that is nothing but 1 by determinant A into adj A. You need to calculate. So that is A inverse will become here 1 by determinant A value is 3 here, adjoint A is here. We are getting 4, 3 minus 1, 0 we are getting. Now final step we need to do, that is B inverse A into 5. B inverse A inverse, you need to multiply. What is the B inverse value? We are having A inverse value, this one. We will do in some other pages. Here RHS is B inverse A inverse. I have written here. B inverse value I have wrote here, and A inverse value we have written. First we will multiply scalar. 1 into 1 we are getting. 2 3s are 6 we are getting. And then now you need to do 7 method. This first row, this column you need to multiply. Or you want write it one time, no problem. There should not be a confusion here. So 4 3 minus 1 0 I have written here. Now you need to multiply. So in short, minus 1 into 4 minus 4, 3 into minus 3 minus 3 you are getting. Minus 1 into 3 minus 3, 3 into 0 no need to write. This is over. Then second row, first column, 0 4s are 0, minus into minus plus 2 1s are 2 we are getting, and 0 into 3 0, minus 2 into 0 0 we are getting. So we are getting as 1 by 6, and this is minus 4 minus 3 is minus 7, this is minus 3, and this is 2, this is 0, this is equation 2. Now you can see here LHS is 1 by 6 minus 7 minus 3 2 0 is there. RHS value we are getting same, 1 by 6 minus 7 minus 3 2 0. So here also equation 1 equal to equation 2, LHS equal to RHS, hence we have proved this one. That's the thing we proved. That's all about this one.